Sir,
Yeah.
you can start, sir.
Okay, fine. I will start now. Okay. So up to this, we discussed about three-membered ring, four-membered ring. So three-membered ring with nitrogen is called azerine, and three-membered ring with oxygen is called oxirane. Similarly, four-membered ring with nitrogen is called acetane. Four-membered ring with oxygen is called oxetane. And now we will discuss about the thietane. Thietane means a four-membered ring with sulfur.
Sir, sorry to interrupt. Many are waiting, sir.
Okay, I will give. No, I think no one is waiting. So they're supposed to go to all classes and there they can enter.
Okay, sir.
I will give once they are here. There is a icon called admit. I will give that. Okay, right. So thietane, a four-membered ring with sulfur as the heteroatom. So let's look into it's also called as 1,3-propylene sulfide. So it's also called trimethylene sulfide. Okay, it's also called thiacyclobutane. Thiacyclobutane. Okay, so now let's look into the chemical properties, more particularly the ring opening reactions. Thietane molecule is less reactive compared to the thyrane. Thyrane is a three-membered ring with sulfur. So that means thietane molecule is what it means. It means thyrane, a three-membered ring with sulfur, is more reactive compared to the four-membered sulfur containing one called thietane. It is due to lower strain. In the thietane, will have a less strain compared to the thyrane. Okay, so then, so let's look into the ring opening reactions. So this is the one is called thietane, and this one, when it is treated with amine is a nucleophile, and it can attack this carbon as well as this carbon, forming a aminothiol. Aminothiol is the general name for this molecule. If you are looking at it by a particular name, so this will be the 1, 2, 3. So 3 mercapto propyl amine is the IUPAC name of this molecule. So thietane also react with a acylating agent. So acylating agent here it's called acetyl chloride. But this acylating reagent, so what will happen? So you know that the lone pair present on the sulfur, it will react with the electron deficient carbonyl carbon, forming a compound like this. So then the leaving group Cl minus can attack this carbon, and there will be a breakage between this carbon and sulfur, forming a compound like this. So what you can say that a electron deficient means what you call electrophile or a nucleophile. Both can leads to the ring opening of thietane. So with this, I will go to the next slide. I will go to the next slide. Okay. Okay, so I will take a pointer. Right. So now you can look into the formation of quaternary salt. So in this, what you call the thietane, when it is treated with alkyl halide. So here I am taking an example of methyl halide, but one can take ethyl bromide, benzyl chloride or bromide or iodide, whatever it is. So overall, a thietane sulfur atom having the lone pair, that lone pair can attack a electrophile, and here iodine will go out. So there will be a formation of protonated alkylated one. And at this stage, the high minus or Cl minus or bromide minus can attack this carbon as well as this carbon, because both are equivalent one. If it is a unsymmetrical one, it's a different case. Here, both the carbon are symmetrical one. So there will be a cleavage here, and there will be a bond formation to this carbon. Iodine is attacking, forming a compound like this. Open strain structure is obtained. Ring strain is converted into open strain. Later on stage, again, one more equivalent of methyl halide or methyl chloride react with this and forming a quaternary salt. Overall, what will happen? So thietane on reaction with excess amount of methyl halide or alkyl halide or aryl halide, so giving rise to quaternary salt. And similarly, let's look into the oxidation. Thietane is usually oxidized by HI. This is called hydroiodic. No, it's not hydroiodic acid. It's a oxidizing agent. So more particularly, oxidizing agent called hydrogen peroxide, H2O2, to produce sulfoxide. Okay, this compound is called sulfoxide. Yes, O2 is called sulfoxide, and eventually the sulfone. This is sulfoxide, and this one will be the sulfone. So thietane and reaction with hydrogen peroxide, giving rise to sulfoxide initially. If it is a excess amount of hydrogen peroxide is there, so that can react forming sulfone. So with this, I will go to the next slide. So next slide, we are taking the benzo-fused heterocycles. So this is the benzene, and this is a 5-membered ring called furan. So benzo-fused furan is called benzofuran. So now onwards, we will discuss about the benzo-fused heterocycles. For example, benzofuran, benzo thiophene. If it is a sulfur, it's called benzothiophene. So up to this, we discussed 3-membered rings, 4-membered rings. So 3-membered rings, azirine, oxirane. Yes, azirine, oxirane, and thiorane. Okay, 3 compounds we discussed in the 3-membered structure. And the 4-membered one, oxetane, azetane, oxetane, thietane. Okay, 3 sulfur containing, oxygen containing, nitrogen containing. Three examples of 3-membered ring, 3 examples of 4-membered ring, more particularly oxygen containing one, sulfur containing one, and nitrogen containing one we discussed. So more particularly, we discussed about the ring opening reactions, oxidation reactions, and derivatives. Okay, now onwards, we will discuss about the benzo-fused heterocycles. So this is one example of benzo-fused, and the name of this compound is called benzofuran. And more particularly, if we are looking into the resonance forums, the lone pair present on the oxygen can come over here. Once the lone pair is coming over here, forming a bond, this bonded pair will sit over here. There is a bonded pair, means anion here. So this anion can come over here, and this bond pair will sit on this carbon. That's what I have written here. So later on, this bond pair or anion can come over here. This bond pair will sit on this carbon. That's what I have written here. This anion can come over here. This bond pair will sit and convert as a anion. So later stage, so this anion can come over here. This anion can come over here. This bonded pair will convert as a lone pair. That's about this. So how many you can form? This is 1, 2, 3, 4. So 4 resonance forums are possible. If there is a more number of resonance forums or canonical forums are formed, then such compounds are stable. So this is about the resonance forms of benzofuran. So with this, I will go to the next slide. So next slide is about the how one can synthesize benzofuran. So here we are taking a name reaction, more particularly Claisen rearrangement. So Claisen rearrangement means this is the starting material. What is the name of this starting material? Aryl. So this group is called aryl group. Two position means this one. Clo. Prop means 1, 2, 3. Prop. Okay. Ene. Second position. Ene position. This is 1, 2. Second position. Ene is there. Okay. In either undergoes Claisen rearrangement or Claisen rearrangement on heating to give. Okay, so what you can observe here. So this is what we can say phenyl allyl ether. In general name, what we can say that phenyl allyl ether. So more particularly, I think this type of rearrangement you come across in a pericyclic reactions, more particularly sigmatropic rearrangement. So this just on heating, it cyclizes forming a 2-methyl, 2-methyl benzofuran. So how it is cyclizes, you can just look into this transition state. So you can observe that this is the oxygen. So from this 1, 2, 3. So 1, 2, 3. So similarly 1, 2, 3. So then it's called a 3-3 sigmatropic rearrangement. So here 6 electrons are involved. How the 6 electrons involved? So what this bond pair, that means this carbon and this carbon, there will be a new bond formation. And so this double bond is converted into a single bond. So that means here there will be a new bond formation, and this single bond is converted into a double bond. Okay, so this conversion of aryl allyl ether, this one is called a 3-3 sigmatropic rearrangement. Then what will happen? So this bond pair is coming over here, and this bond pair picks up this proton, and the conversion of this to this is called 1,3 hydrogen shift. Okay, then afterwards what will happen? The lone pair or the bond pair can attack this carbon, and this can picks up a proton. A intermediate is formed like this. Then afterwards elimination reaction. So HCl will go out. How it will go? This bond pair is coming over here. Cl minus will go out. So that is how the benzofuran is obtained. So overall, what you need to remember, so one can synthesize benzofuran by the name reaction called Claisen rearrangement. And so what is the starting material name? Starting material name is, this compound is aryl and this is allyl. So aryl, allyl ether can be used as the starting material. And here, if you are writing the mechanism, so this will be the 3-3 sigmatropic rearrangement. So from here to here is a 1,3 hydrogen shift. 1,3 means you can write, so 1, 2, 3. 1,3 sigmatropic shift, hydrogen shift. This is the one. And there will be a reaction between the lone pair or the bond pair to this carbon electron deficient. So this bonded pair is moving over, picks up this proton, forming this compound. Later on, elimination reaction. This bond pair is coming over, Cl will go out, forming a benzofuran compound. So with this, I will go to the next slide. So next slide. Okay, I will move now. Right. So method 2. So here there will be involvement of organometallic reagent. So this is only a reagent. So what will happen here? There will be a reaction between the lone pair or the bond pair to this carbon, and similarly there will be a new bond formation between this carbon as well as this carbon. So for this reaction is facilitated by the catalytic reagent, organometallic reagent. By using this, one can convert a iodophenol into a hydroxymethyl. So this is hydroxy, this one is methyl, hydroxymethyl benzofuran. So these are the two methods. By this one can prepare or synthesize the benzofuran. Okay. So with this, I will go to the next slide. So next slide is about the chemical properties. So chemical properties means you know that what is called as uh, since it is a aromatic moiety, one can think about the electrophilic substitution reaction. So electrophilic substitution means it's a characteristic property of an aromatic compound. Of course, benzofuran is a aromatic compound. So, and we should know where the electrophile attack. So here in this benzofuran, the second position is the electron-rich species, and that is where electrophile attacks. So here I'm discussing the few electrophilic substitution reaction. So here you know that so benzofuran, when it is treating with a nitrating mixture, so HNO3 is a nitrating agent. So nitrating agent means it will supply NO2 plus electrophile. So the second position means this bonded pair can attack NO2 and later on, I think you know that nitration process. Nitration means initiation, initiation of electrophile, attack of electrophile, and elimination of proton. 3 steps are involved in nitration process, and the obtained product is 2-nitro-benzofuran. Similarly, when benzofuran is treated with alkyl halide, so alkyl halide may be a methyl halide or bromide, methyl bromide or methyl chloride or ethyl chloride or propyl chloride, isopropyl chloride, whatever it is. So here I am taking a general alkyl halide. So alkyl halide, when it is treated with aluminum chloride, this is also a name reaction. More particularly, it's called as a Friedel-Crafts alkylation. So Friedel-Crafts alkylation. What will happen here? So there will be a new bond formation. So this is also a electrophilic substitution reaction, because there will be a formation of R plus. R plus means alkylonium cation. So then the bond pair can attack this electrophile, forming a product, and it is a electrophilic substitution reaction. More particularly, it's a name reaction called as Friedel-Crafts reaction. So in the Friedel-Crafts, 2 types. One is alkylation, another one is acylation. So here alkyl is used. That is the reason it's alkylation. Of course, R can be acyl also. Acyl means CO containing one. Then if R is an acyl group, then you can say that Friedel-Crafts acylation reaction. It is also possible to do one more name reaction. Name reaction is called Wills-Meyer-Hack reaction. So Wills-Meyer-Hack reaction means the reagent is POCl3 and DMF. So what is DMF? DMF is a dimethyl formamide. Dimethyl formamide is called DMF. So what will happen here? So this will act as a source of CHO. So CHO is attacks on the second position of the benzofuran, forming 2-formyl. Now the substituent, second position, 2-formyl benzofuran is the product obtained. So these reactions is about the electrophilic substitution reactions of benzofuran. Benzofuran. So with this, I will go to the next slide. So next slide is about the oxidation. So here we are taking the example of, I think you are aware, instead of this group, if there is a HH is called hydrogen peroxide. H2O2 is the hydrogen peroxide. So this one, dimethyl oxirane, more particularly dioxirane, is an oxidizing agent. So what it will do, it will act as a source of oxygen, and it will convert a double bond to the epoxide. So epoxide is formed here. So this is about the substituted benzofuran. So substituted benzofuran, when it is treated with the dimethyl dioxirane, epoxide is formed. So this is nothing but an example of oxidation of benzofuran. So with this, I will go to the next slide. So next slide is about the reduction. I think reduction, you know that reduction is nothing but a addition of hydrogen, addition of electron, removal of oxygen is called reduction. So here one can use the reducing agent such as sodium in ethanol. Sodium in ethanol is the one reducing agent, and this reducing agent is called Birch reduction. So what will happen? Birch reduction means here the product obtained is 2,3-dihydrobenzofuran. So here you know that. So in this benzofuran there is a double bond. So but here there is no double bond. So the double bond is replaced with hydrogen. So here the sodium will act as a source of electron. So you know that sodium can can give one electron to become a Na plus. So 2 molecule of sodium can give 2 electrons, thereby leads to the formation of bond. Okay, so that means 2 sodium can give 2 electrons to here, and that 2 electron can form a bond with the proton. And here ethanol is the source of proton, and this bond pair can form a one more bond with the proton of the ethanol. So that is of course, maybe what you can do, you can try to write the mechanism for the conversion of benzofuran to the dihydrobenzofuran. It is nothing but a Birch reduction. It follows a Birch reduction mechanism. So maybe just I will explain this. Na give rise to 1 electron to this carbon, and this what you call bond pair will sit on here as a anion. So this bond pair can pick up a proton from the ethanol, converted into CH. So later one more sodium will give one more electron to this carbon. Then 2 electrons are there. That 2 electron can abstract a proton from ethanol. So converted into 2,3-dihydrobenzofuran. So I will take one more example. So here stannous chloride. Stannous chloride is also another reducing agent. How it will reduce? Stannous gets converted into stannic. Okay, stannic is the okay. I think it's this is a stannous means Sn plus 2. Stannic means Sn plus 4, isn't it? So here, yes. So this is this will act as a source of electron. So this will give electrons to the nitro group. So nitro gets converted into NH2. Okay. So all these things comes under the dissolved metal reductions. So maybe you just look into the maybe the books Advanced Organic Chemistry by Coldham. Okay, Carothers and Coldham. Okay, maybe the 6th edition or 7th edition. So in that you can just look into the dissolved metal reductions. Okay, so in that you can find the mechanism. More particularly, general mechanism is, so this one will give a proton. So this one will give a electron. So that those electron will come and sit on the nitrogen. So O minus can picks up a proton. So usually stannous chloride means it is nothing but a tin in HCl. SN means is nothing but a tin. Okay, tin in HCl. Tin will give electron. So, and after giving electron, tin is gets converted into stannic and then stannous. So this should be the living group. So this is the stannous chloride is a living group. But what is the reagent here? The reagent should be tin, SN in HCl. SN in HCl is the reagent. SnCl4 is the living group. Okay, so Sn is gets converted into SnCl4 after giving electrons to the nitro group. Those electrons are used by nitro group converted into NH2. And once the NH2 is obtained, so you know that the what you call a proton is shifted from NH to here. It's called 1,3 hydrogen shift. And after shifting a proton from here, the obtained one is called imine. So this imine on hydrolysis gives benzofuranone. So why it is interested here? So when we are the reaction is carried out, so more particularly 2-nitro-benzofuran when it is treated with the tin in HCl, so the expected product is 2-amino-benzofuran, but the obtained one is benzofuranone. Okay, that is interested one while doing reduction of nitro group in benzofuran. So with this, I will go to the next slide. Maybe what you can do, you can also try to write the mechanism for the conversion of nitro group to amino group using tin in HCl. Okay, that also you can try. So with this, I will go to the next slide. So next, so that's all about the benzofuran. So now I am taking the benzothiophenone. So benzothiophenone means it's nothing but a thiophene. Thiophene fused benzene. Thiophene fused benzene is called benzothiophenone. So similar to the benzofuran, thiophene also shows resonance property. So you can, this sulfur is also having lone pair. That lone pair can come over here. Once the lone pair is coming over here, this bond pair will sit on this carbon. So that's what I have written here. So later, this bond pair can come over here and this bond pair will sit over on this carbon. So that's what I have written here. And this anion will come over here. This bond pair will sit on this carbon. So that's what I have written here. Then this bond pair will come over here and this bond pair will sit on this carbon. So later stage, so this bond pair can come over here, this bond pair can come over here, and this bond pair will convert as a lone pair of sulfur. So with this, these are about the resonance forums. So what you can observe, there are 4 resonance forums or canonical forums are available. So if there is a more number of resonance forum, the aromatic compound is more stable. So with this, I will go to the next slide. So next slide is about the synthetic methods of the preparation of benzothiophenone. I think you know that you just look into this. This group is called this double bond Cl is called vinyl chloride group. And this SH group is called mercaptan. So what it means, a aromatic compound which is having a vinyl chloride and mercaptan containing one. So when it is treated with alcoholic KOH, what is alcoholic KOH? So KOH is dissolved in alcohol. What is KOH? Potassium hydroxide. When it is dissolved in alcohol like ethanol or methanol, that is called as alcoholic KOH. So what will happen here? There will be a removal of dehydrohalogenation. So dehydrohalogenation means removal of HCl. So maybe what we can say that the lone pair or the bond pair can attack this vinylic carbon. This carbon is called vinylic carbon and Cl will go out. So here the HCl is going and forming a benzothiophene. This is one method of preparation of benzothiophene. So what it means, benzothiophene can be obtained starting with the mercaptovinyl chloride analog of benzene when it is treated with alcoholic KOH, so giving rise to benzothiophene. One more method, so from the keto sulfide, this is called keto group, and this group is called sulfide. So it is also, one can prepare benzothiophene starting with keto sulfide. This is the keto, this is the sulfide. So when it is treated with PPA, I think you know that PPA, applications of PPA. PPA means polyphosphoric acid. So what its role? Its role is dehydration. So removal of water. How the removal of water takes place? One H from here, another H from here, and O. So H2O will go out, and there will be a new bond formation between this carbon and then this carbon, and similarly there will be a new double bond formation between this carbon and this carbon. Okay, so forming a benzothiophene as the product. So these are the two methods of preparation of benzothiophene. So with this, I will go to the next slide. Okay, next slide. 1 minute. Next slide. Right, I think now it will come. Okay, so next I'm talking about the Diels-Alder method of preparation of benzothiophene. So I think you are aware about the 4n plus 2 pi electron cyclo addition. So 4 plus 2 pi electron cyclo addition here I am taking. So this is called succinic anhydride. So this is called succinic anhydride. How you can get this succinic anhydride? So succinic acid on dehydration. So just you take the succinic acid in RB, fix a condenser, just heat it until the maybe above 100 degree. So you will get a succinic anhydride. Here water should remove. After that you will get a succinic anhydride. So this is a dienophile, and this one is called a diene. So Diels-Alder reaction means you should aware about the what is diene, what is dienophile. So this is diene, conjugated one is called diene, and other should be a dienophile. Dienophile means along with the double bond there should be a electron withdrawing groups containing ones are called dienophile. So the reaction of diene and dienophile is called a what you call pericyclic reactions. More particularly, what we can observe here, this is a diene, and how many electrons are here? This is 2 electrons, this is 2 electrons. That means that is the reason 4 pi electrons, and here 2 electrons. So 4 plus 2 pi electron system, cyclo addition. How these are going to cyclo addition? There will be a new bond formation between this carbon as well as this carbon. There will be a new bond formation between this carbon and this carbon, and there will be a new double bond formation here. So how we can show that? This bond pair is coming over here, this bond pair is coming over here, this bond pair is leads to a formation of bond formation like this, giving rise to an intermediate like this. So later on, this on decarboxylation. Decarboxylation means removal of carbon dioxide, and also removal of what you call decarbonylation, decarboxylation, decarbonylation. So so what will happen? Once there is a decarbonylation and the decarboxylation, there will be a double bond here. So later stage, there will be a dehydrogenation. So dehydrogenation means removal of